Good evening, sir.
Good evening. One second, I'll be back.
ಏ ತಗೊಳ್ಳಲ್ಲ ಮಂದಿ ಏ ಗೂಬೆ ತಗೋ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಶುರುವಾಗದಲ್ಲೋ ಸೈನ್ಸ್ ಆಯ್ತು
Yes. Good evening, everyone.
Good evening, sir.
Good evening, sir.
Good evening, everybody.
Good evening, sir.
Good evening. Good evening. Okay. So, till how many questions we discussed? Exercise part.
3, sir.
Okay. Can you read out? Can anybody read out the fourth question? Okay, I'll call the student. Vishwa speaking. Vishwa speaking. Do you have got book with you? Textbook? Charan? Okay. Charan Venkatesh,
Yes, sir.
can you read that fourth question?
Just a minute, sir. Just a minute.
Yeah.
Opening. Sir.
Up to question number 3 we have discussed, right?
Yes, sir.
Yesterday.
Sir, question number 4th one, sir.
Yeah.
Yeah, what is a balanced chemical equation? Why should chemical equations be balanced?
Okay, what is balanced chemical equation and why should we balance the chemical equation? Yes. What should be your answer? See, why we have to balance the chemical equation? We know that we cannot create any substance. I mean, matter can neither be created nor be destroyed, but can be transferred from one form to the other form, right? That's called law of conservation of mass. So mass can neither be created nor be destroyed. It can be transferred from one form to the other form. Similarly, energy. So this is the law of conservation of mass and law of conservation of energy. We cannot create and we cannot destroy, but we can only transfer. So when we are obeying this law of conservation of mass, we have to balance chemical equation. Number of atoms present on the reactant side should be equal to the number of atoms present on the product side of particular type. Say, for example, carbon. How many carbon atoms are present on the reactant side? The same number of carbon atoms should be present on the product side, like other atoms. Okay. So that is why we have to balance chemical equation. Got it? Hope it's clear, everyone.
Yes, sir.
Okay. Shall we move on to the next question?
Yes, sir.
Yes. Can anybody read the next question? Fifth question.
Translate the following statements
Translate
into.
of
Yeah, Charan, go ahead.
Yes, sir. Translate the following statements into chemical equations and then balance them. First one.
Okay.
Yes, sir.
Yeah.
First one. Hydrogen gas combines with nitrogen to form ammonia.
Hydrogen gas combines with nitrogen to form ammonia. Hydrogen gas that combines with nitrogen form ammonia. See, whenever we say hydrogen, you always should write H2. Whenever we say nitrogen, you always should write N2. Okay. Because hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, all of them exist in the form of diatomic molecules in nature. So whenever you are writing the reactions, whenever you are taking hydrogen, you have to write it as H2, nitrogen, N2, and when they combine, they form ammonia. Is it balanced? No. Left hand side, we have got 2 nitrogen atoms and 1 nitrogen molecule. But while balancing, we have to look into the number of atoms, right? So we have got 2 nitrogen atoms, right? But on the product side, we have got only 1 nitrogen atom. Therefore, it should be 2 NH3. Now, 2 into 3, 6. There are 6 hydrogen atoms. Here we have got only 2 hydrogen atoms. So it has to be 3H2. So 3H2 plus N2 gives 2 NH3. And you can also write the physical state, also mention the physical state. H2 gas plus N2 gas gives NH3 gas, and it should be 3H2 plus N2 gives 2 NH3. Hope that's clear?
Yes, sir.
Yes, this is the first one. Second one,
Hydrogen sulfide gas burns in air to give water and sulfur dioxide.
pardon,
Hydrogen sulfide gas burns in air to give water and sulfur dioxide.
water and sulfur dioxide. Huh?
Yes, sir.
Okay. Sulfur dioxide means SO2. Water, H2O. Yes. H2S, hydrogen sulfide gas. Hydrogen sulfide, when it burns in air. So whenever we are taking air, we consider only the oxygen. Okay. O2 gas gives SO2 plus H2O. Yes. Hydrogen balance. Sulfur balance. 1 sulfur atom, 1 sulfur. 2 hydrogen atoms, 2 hydrogen atoms. Right? Now oxygen atoms, how many oxygen atoms? 2 plus 1, 3. Right? So how many oxygen atoms we could write? We can directly write 3 by 2. 3 by 2 is nothing but 1.5. 1.5 to 2 is nothing but 3. So 3 oxygen atoms, 3 oxygen atoms. ಇಲ್ಲ ಇನ್ನೊಂದರ ಯಾವ ತರ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬಹುದು H2S plus O2 gives SO2 plus H2O. So here, if we write 2H2O, and here it should be 2H2S, then here it should be 2SO, right? 4 hydrogen atoms, 4 hydrogen atoms. 2 sulfur atoms, 2 sulfur atoms. Now, how many oxygen atoms? 2 into 2, 4. 4 plus 2, 6. So here it should be 3O. Like this also we can balance. This is also balanced equation and this also balanced. In both the way we can balance. Hope that is clear.
Yes, sir.
Everyone understood?
Yes, sir.
Okay. Any other reaction is there, Charan?
So still two are there, sir.
Okay. Tell me the third one.
Yes, the third one. Barium chloride reacts with aluminium sulfate.
Once again, one by one, tell me. Barium
Okay.
chloride.
Yes, sir. Barium chloride.
That means BaCl2. Barium
Yes,
chloride
sir.
formula BaCl2
Reacts with aluminium sulfate
reacts with aluminium sulfate Al2.
to,
Guys,
to give aluminium chloride
to give aluminium chloride AlCl3
and a precipitate of barium sulfate.
and a okay. Shall I erase this? This can I erase?
Yes, sir.
Okay. Everyone, please mute your audio. Everyone, please mute yourself. Sanika, Sanika, can you please mute yourself? BaCl2, barium chloride plus aluminium sulfate gives aluminium chloride plus precipitate of barium sulfate. If you mention that downward arrow, that indicates it is precipitating, getting precipitated. Okay, downward arrow. Fine. Here SO4 thrice we have. That means has to be 3 BaSO4. Al2 it is there, so here it should be 2 AlCl. Right? 3 Ba is there. So here it should be
Sir, 3.
3 BaCl. 3 2s are 6 chlorine atoms, and here also 3 is 6 chlorine atoms. 2 aluminium, 2 aluminium. SO4 thrice 3 SO4. 3 Ba, 3 Ba. Yes, it is balanced, right?
Yes, sir.
Yes, sir.
Great. Can you write this? Yes, next one.
Potassium metal
Potassium metal
reacts with water
reacts with water,
to give potassium hydroxide
potassium hydroxide, formula KOH,
and hydrogen gas.
and hydrogen. Right. So always remember formula potassium hydroxide KOH, K plus OH minus, right? In all these cases, I hope you remember this because I explained this before I start this chapter. How to write the formula. Let me explain once again quickly. Barium chloride, barium, its charge is 2 plus, and chloride Cl minus. So this charge we write here and this charge we write here. In that case, Ca minus 1. So it is 1 Cl2 because this 2 plus. This we write here. So BaCl, and this charge we write here. BaCl. Similarly, aluminium sulfate. Aluminium, its charge is 3 plus, and sulfate, its charge is 2 minus. So when we write aluminium here, this sulfate charge we write here, then it should be Al2. And 3 plus, this charge we write here, and it will open the bracket SO4, then write 3, or else it may look like 43. That is why we have to put bracket, right? And this is multi-atomic radical. So the formula will be Al2SO4 thrice. because of the charge of aluminium is +3 and the charge on sulfate is 2 minus. Got it? Aluminium chloride. Al3 plus Cl minus, so it is AlCl. Barium sulfate, similarly, barium its charge is 2 plus and SO4 2 minus, and this charge we write here, this charge we write here, so it will be barium sulfate BaSO4. Got it? Similarly, potassium hydroxide KOH, K plus OH minus, so it is KOH. Is it balanced?
2K.
H2H3 is there, 3 or, and here we cannot write, so we can write 2 KOH, 2 hydrogen atom, 4, so we can write 2H2O, 4 hydrogen atom, 2 oxygen atom, 2 oxygen balance. Isn't it? So the reaction is balanced, right?
Yeah.
Fine. Any other questions there?
No, sir. Balancing it, the equation finished.
Finished. Next question number.
Now we have to go
6.
for 6th, sir.
Okay, 6th one. Yes, can you repeat 6th one? Question number 6.
Yes, sir. Balance the following chemical equations. Is the session?
Balance the following equations. Okay, can you please tell me one by one?
Yes, sir. First one is HNO3 plus Ca of OH2. That gives Ca of NO3 twice plus H2O.
This is the reaction. HNO3 plus CaOH twice gives CaNO3 twice plus H2O, right?
Yes, sir.
HNO3, nitric acid. Nitric acid reacts with calcium hydroxide, gives calcium nitrate, and gives H2O. Now this is acid, HNO3, nitric acid, acid, calcium hydroxide. Gives salt and water that you are going to study in your next chapter, right? Acids, bases, and salts. Fine. So let's balance now. Here it is NO3 twice. So here we have NO3. It is actually NO3 minus H plus. That's how it has formed. So here we have got NO3 twice. That means here we should have 2 HNO. Okay. 2 HNO3. Now hydrogen atom. 2. Here 2, 4. So 4 means here we can write 2H2. When we write 2H2, we write 2 oxygen atoms. And here 2 oxygen atoms. Next it is balanced. Two HNO3 plus CaOH twice gives CaNO3 twice plus 2H2O. It's balanced.
Yes, sir.
Okay. Next question.
NaOH.
NaOH.
Yes.
Okay. NaOH
Plus H2SO4
plus H2SO4
gives raised to Na2SO4. plus H2O.
NaSO4 plus H2O. This is also like NaOH plus H2SO4 gives Na2SO4 plus H2O. Base, acid base gives salt plus water. Same acid base reaction. Here it is Na2SO4, therefore it will be 2NaO. Correct? 2 into 1 hydrogen atom. So 2 hydrogen atoms and here 2, 4 hydrogen atoms. Therefore, it should be 2H2. SO4, SO4. Is it balanced? Yes, it's balanced. Right?
Yes, sir.
Okay, next question.
NaCl
NaCl
plus AgNO3
plus AgNO3
give rise to AgCl
AgCl plus
NaNO3.
NaNO3. You don't need to balance this, is already balanced, right? Balance, no double displacement reaction. It's also called precipitation reaction. It's a double displacement reaction. AgCl gets precipitated. It's already balanced. Yes or no?
Yes, sir.
Yes, sir.
Yes. Can I move on to the next one?
BaCl2.
One second.
Yes, sir. Yes.
Tell me, BaCl2. No?
Yes, sir. BaCl2 plus H2SO4 gives BaSO4 plus HCl.
Right?
Yes, sir.
Here also SO4 displaced Cl minus here. Therefore, SO4 came. And Cl2 displaced. That means here only one Cl. 2H here. H2, 2H. Yes. Balance.
Yes, sir.
Yes, sir.
Yeah. Yes. Next question.
Sir, no, for seventh one.
Okay. We move on to the seventh question.
Yes, sir. That is,
Yeah.
write the balanced chemical equations for the following reactions.
Okay. We have to write the balanced chemical equation for some reactions, right?
Yes, sir.
Once. You will read the question.
So first one is calcium hydroxide plus
Calcium hydroxide, CaOH twice is the formula of calcium hydroxide
plus carbon dioxide
plus carbon dioxide, formula is CO2,
gives calcium carbonate plus water.
gives calcium carbonate formula is K2 plus H2O. I gave you the formula of radicals, formula and charges of the radicals, right? In the first class itself, beginning, I gave the charge of radicals. Carbonate, its charge is 2 minus. Calcium, its charge is 2 plus. Hence the formula will be CaCO3. And this is CaOH. This is how we write the reaction. Got it?
Yes, sir.
Yes, sir.
Yes. Next one.
Zinc plus silver nitrate
Zinc, Zn plus silver nitrate, AgNO3.
gives zinc nitrate plus silver.
Zinc nitrate, what is the formula of zinc nitrate? Zinc charge is 2 plus, nitrate charge is NO3 minus, nitrate is a radical. NO3 minus, Zn2 plus. Then it should be Zn NO3 twice. Correct? So
Plus
zinc
silver.
that has displaced silver. Zinc has displaced the silver from silver nitrate solution. Ag. Therefore, it's a displacement reaction. NO3 twice. So it has to be 2 AgNO3 and here it will be 2 Ag. The displacement reaction. Many reactions I gave in displacement reactions. Hope you remember. Right? Yes. Shall we move on to the next one?
Yes. Sir.
Yeah.
Aluminium plus copper chloride
Aluminium plus CuCl2.
gives aluminium chloride plus copper.
Yeah. This is also displacement reaction. This is also displacement reaction. Aluminium plus CuCl2 gives AlCl3 plus Cu. Aluminium, copper chloride, aluminium chloride, and copper. AlCl3. So here we have got 2. The next common number should be 6 in the sense. Take 3 CuCl2, 2 AlCl3, 3 Cu, and 2 Al. Got it?
Yes, sir.
Yes, sir.
Super. Fantastic. Next one.
Barium chloride plus potassium
Barium
sulfate
chloride. That means BaCl
plus potassium sulfate
plus potassium sulfate. K2SO4. This will give barium sulfate, BaSO4 plus KCl. Potassium chloride. Double displacement reaction. Barium chloride plus K2SO4 barium sulfate plus KCl. Here K2 is there, so it should be 2K. Here is there 2 KCl, that's balance, and BaSO. Fantastic, right? Isn't it?
Yes, sir.
Yes. Next one.
Next
Sir, now
question,
eighth
sir.
one.
Okay, we have to on to the next question. 8th question. Yes.
That is, write the balanced chemical equation for the following and identify the type of reaction in each case.
Okay, you have to balance the reaction and you have to identify which type of reaction is it, right?
Yes, sir.
Okay, yeah. Can you please tell me one by one?
Yes, the first one, potassium bromide
Potassium bromide, formula is KBr.
potassium bromide plus barium iodide
It's barium iodide, BAI. So,
give
now,
yes,
one
sir.
second. This is potassium bromide, K plus Br minus, plus barium iodide, AI2 it should be. This is I minus Ba2 plus, right? So it should be AI2. KBr, this is K plus Br minus, that is why KBr. This is actually Ba2 plus and I minus, that is why formula should be. See, there is no other way. It has to be double displacement reaction. Because K plus and Ba2 plus, they are positively charged, right? Two positively charged species cannot combine. Two positively charged ions cannot combine. So I minus should come with potassium and this Br minus should go with barium. That is why the product will be Ai, potassium iodide, plus barium bromide, Br2. They have given potassium iodide and barium bromide, right?
Yes, sir.
Product side. Yes or no?
Yes, sir.
That's the reason. It has to be double displacement reaction. BaBr2. Br2 means here it should be 2 KTR. And here it should be 2 KI. I2, yes. Balance. So the reaction is double displacement reaction, or it's also called precipitation reaction, isn't it? Next one,
Zinc carbonate
zinc carbonate ZnCO3.
gives zinc oxide plus carbon dioxide.
Okay. Gives zinc oxide plus carbon dioxide. There is only one compound which is giving two products. If one reactant gives two products, or two or more than two products, then it should be decomposition, right?
Yes, sir.
Great. Yes. Next one.
Hydrogen plus chlorine
Hydrogen is formula H2. Chlorine is the formula Cl2. H2 plus Cl2, it should give 2 HCl. It's a combination reaction. There is no other way. Only HCl should be the product.
Yes, sir.
Hope that's clear, everyone.
Yes, sir.
Everyone understood?
Yes, sir.
Yes,
How
sir.
all these reactions? Yes, next.
Magnesium plus hydrochloric acid
Magnesium plus hydrochloric acid formula HCl gives MgCl2 plus H2, magnesium chloride and hydrogen. Correct? Product.
Displacement reaction.
Absolutely. This is a displacement reaction. MgCl2 it is next to HCl and H2. Yes, balance. Magnesium is displacing hydrogen from hydrochloric acid. So in case of magnesium, you can take aluminium, you can take zinc, you can take potassium, you can take iron, you can take nickel. Got it? All reactive metals, they are all called reactive metals. Calcium, magnesium, sodium, potassium, zinc, iron, nickel, chromium, they're all called reactive metals. They displace hydrogen from dilute acid. So the reaction name is displacement reaction. Good. Any other reactions are there?
No, sir. Ninth one.
Okay, we move on to 9th question. Yes.
What does one mean by exothermic and endothermic reactions? Give example.
Exothermic and endothermic reactions. Give examples. See, you have already studied. If only one reactant is giving two or more than two products, that reaction is called a decomposition reaction, right? If some substance has to decompose, means you have to supply energy. Then only they can get decomposed. So all decomposition reaction, you can say, all decomposition reactions are endothermic. If one reactant is giving more than one products, if it is decomposition reaction, then it should be endothermic. Now the question is, what is endothermic? N means in, thermic means heat. So in any particular chemical reaction, if heat is flowing into the reaction, then that reaction is called endothermic reaction. The reverse of decomposition reaction is combination reaction. One or two reactants combine together and giving product. Right? One or two reactants combining together to give product. There, heat is liberating. Exothermic. Exo means out and thermic means heat. So heat comes out, energy comes out. So in all exothermic reaction, heat liberates. So if any chemical reaction proceeds with liberation of heat, if any chemical reaction proceeds with liberation of heat or liberation of energy, then that reaction is called exothermic reaction. Examples, all combination reactions. Just now you wrote H2 plus Cl2 gives 2HCl, right? Hope that's clear.
Sir,
Yes, sir.
sir, for exothermic reaction, even respiration is an example, no, sir?
Correct. Even respiration is also exothermic reaction. And combustion reaction. Combustion reactions are also example. Combustion of methane, CH4 plus O2 gives CO2 plus H2 is there, right? All combustion reactions are exothermic reactions. All combustion reactions are exothermic reactions, and all combination reactions are also exothermic reactions. Understood?
Yes, sir.
Yes, sir.
Yes. Next question.
So 10th one.
Yeah.
Why is respiration considered an exothermic reaction? Explain.
Yeah. That's what exothermic reaction under in respiration reactions, energy is also one of the product. In respiration reaction, energy is also one of the product. In any chemical reaction, if energy is also one of the product, then that reaction is called exothermic reaction. Like in all combustion reactions also, in all combustion reactions, energy is also one of the products. In all combination reactions, energy is also one of the products. Therefore, combination reactions, respiration, combustion, they're all called exothermic reactions because their energy is also one of the products. Hope that's clear.
Yes, sir.
Yes, sir.
Next one.
11th
Why-
one.
Yeah. Yes, 11th one.
Yes, sir.
Why
Why?
are decomposition reactions called the opposite of combination reactions? Write equations for these questions. Equations.
Okay, can you repeat again?
Yes, sir. Why are decomposition reactions called the opposite of combination reactions? Write equations for this. Write equation for these reactions.
Okay. So should I explain again why combination, why decomposition reactions are the opposite of combination reactions, or why combination reactions are called opposite of decomposition reaction? Should I explain again? We have already discussed, right?
No, sir. No need.
In combination reactions, energy is also one of the products, and in decomposition reactions, energy is also one of the reactants. That means we have to supply energy. Correct?
Yes, sir.
In combination reactions, energy will be released. In decomposition reaction, energy will be consumed. Combination reactions are exothermic in nature. Decomposition reactions are combination reactions are exothermic in nature, and decomposition reactions are endothermic in nature. You can write on the examples. So many examples we have discussed already. Yes. Next one.
12th one, sir.
Yeah.
Write one equation each for decomposition reaction where energy is supplied in the form of heat, light, or electricity.
Yes. Decomposition reaction. One reaction you have already written. Zinc carbonate gives zinc oxide plus carbon dioxide. One more reaction you can write. Calcium carbonate gives calcium oxide and carbon dioxide. Yes or no? Calcium carbonate gives calcium oxide and carbon dioxide. Right? Hope that's clear.
Yes, sir.
decomposition reactions, examples. And I also gave some 4, 5, more than 5 examples, even in each type. Look at those reactions, okay? Understood, everyone?
Yes, sir.
Okay. Yes, next.
13th one, sir.
Yeah.
What is the difference between displacement and double displacement reaction? Write equation for these reactions.
Yeah, we have already discussed the displacement and double displacement reactions. Should I write the reactions again? Hello, I'm asking.
No, sir.
Everyone, already we have written many examples on displacement and double displacement reactions, right?
Yes, sir.
Yes, sir.
Hmm? Yeah. So that is why those examples only you can take. In double displacement reactions, both the species from two species from both the reactants will be displaced to each other. But in a displacement reaction, highly reactive reactant displaces the other reactant. Reactive metals, say for example, reactive metals like magnesium, aluminium, potassium, they displaces hydrogen from dilute acid, right? Got it?
Yes, sir.
Yes, sir.
Yes. So so far, do you have any doubt in all these questions?
No, sir.
No, sir.
Next question.
14th one, sir.
Yeah.
In the refining of silver, the recovery of silver from silver nitrate solution involved displacement by copper metal. Write down the reaction involved.
Copper. So recovery of silver from recovery of silver from silver nitrate solution means AgNO3. From AgNO3 we can get Ag, right? This can be done using copper. So copper is more reactive than silver. Therefore, copper displaces silver from silver nitrate solution. So here Ag, then it forms CuNO3 twice. Copper nitrate. Since it is NO3 twice, there should be 2 AgNO3, then it 2 Ag. This is the reaction. Got it?
Yes, sir.
Yes. So, yes, pardon. Here I finished this chapter, chemical reactions and equations. From my next class onwards, I'll start acids, bases, and salts. Is that chapter completed in your schools?
No,
Yes.
sir.
No, sir.
Yes, sir.
Okay, in some schools it is finished, in some schools it is not. Okay, do you have any doubt in this chemical equations and reactions chapter? Tell me.
No,
Yes,
sir.
anybody, do you have any doubt or
No,
any
sir.
clarification required from this particular chapter?
No, sir.
No,
Hello,
sir.
everyone. At least thumbs up. Sir, there is no doubt and we understood this chapter, everyone. At least thumbs up.
No doubt, sir.
No doubt. Okay. I'm not getting response from everyone.
No doubts.
No doubt, sir.
No doubt, right? All of you understood this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So from next chapter I'll start acids, bases, and salt. That's the second chapter, right?
Yes, sir.
Yes, sir.
Okay. And from this chapter, you will have objective tests from this particular chapter. Okay, we will let you know the dates. And you will have 2 tests, objective tests from this particular chapter. Got it? So you have to go through the entire NCERT textbook. Entire NCERT textbook, you go through that, and we will give objective questions from this chapter. Hope that's clear.
Yes, sir.
Yes, sir.
ಇನ್ನೇನಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ?
No, sir.
No, sir.
Okay. So we will conduct a test, objective test from this particular chapter. Then next class I will start acids, bases, and salt. So just you go through and glance the chapter acids, bases, and salt. Andre eno aa chapter alli enella ide, you just go through once you glance that chapter. Okay. Fine, everyone.
Yes, sir.
ಇನ್ನೇನಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ? ಇನ್ನೇನಾದ್ರೂ ಕೇಳೋದಿದೆಯಾ ನೀವು ರಿಲೇಟೆಡ್ ಟು pertaining to this particular chapter?
No doubt, sir.
Anyone? Do you have any?
No, sir.
No, sir.
All of you understood this? Okay. So then we'll start second chapter from our next class. Okay. Hope that's clear,
Yes.
everyone.
Yes, sir.
Yes, sir.
Okay, guys. Then see you in the next class with new chapter. Okay.
Okay, sir.
Thank you.
Okay.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye, sir.
Bye, sir.
Bye.
Bye and thank you.